All right, now we're in 1.3 and we're looking at example 5. We're going to look at B and C. So we're factoring rational exponents. So we want to always look at the base that each term has in common. So the base that each term has in common is x. And then we're going to look at their powers. Remember, we're always going to take the base with the smallest power. So in this situation, that would be x to the negative 1/3. So we factor that out. So every time we factor out a common factor, we are actually dividing by it. And so when we divide with the same base, that means we subtract their powers. So we just need to subtract that negative 1/3 from each of the base x's powers. So we have x to the 2/3, and I'm going to subtract negative 1/3 from it. Same thing happens with 2x to the negative 1/3. I'm going to subtract 1/3. Now, when we subtract a negative number right here and right here, what we're really doing is we're going to be adding them. So this ends up being the addition of 1/3, the addition of 1/3. So I have x to the negative 1/3, so that's what we factored out. And now we're going to simplify the powers. So 2/3 plus 1/3, so that's x to the 3/3. The minus 2x, negative 1/3 plus 1/3, that's to the 0. So x to the negative 1/3 times, so x to the 3/3 is then x to the 1 power. Remember, the power of 1 is unseen, so we don't write it. When we look at any base raised to a power of 0, so we're using the rule of a to the 0 is equal to 1, except for 0, but in this situation, we have x raised to the power of 0. So it will be equal to 1. So it's just x to the power of 0, that's 1. So I'll still have this 2 that will multiply to this 1. I'll write that power of 1 right here. So that 3 over 3 becomes 1. And we don't typically write it, so I'm going to write this x to negative 1/3, and I really have then x minus 2. That's the end of that one. Okay. Oh, actually, no, it's not. So what we forgot to say that they want it with positive exponents. So we need to finish that. So we're going to get rid of that negative exponent by using, if I have a to the negative n, this is equal then to a to the 1 over a to the n. Okay. So this, I'm going to have to put an equal sign over here so I can make space. This is going to be then 1 over x to the 1/3 times x minus 2, and then we have x minus 2 over x to the 1/3. Now we're done. There we go. So we're going to look at C as well. Okay, very similar. Okay, the only difference here, we had a single term for a base. In this case, I have multiple. I have an expression raised to a power. Now this expression is my base. So this x squared plus 1 is the base of that I'm going to be factoring. That's what they have in common in the numerator. So I'm going to start this way over here so I can have plenty of room to do all this. We're going to go ahead and do the same thing. I'm looking at the numerator first. I'm going to factor. What do they have in common? So they have that base, and they have the bases raised to these two different powers. We're going to factor out the smallest of the two. So with the base, x squared plus 1 and its smallest power. So remember, when we do this, we're really subtracting what we factored out. Missed a negative there. Minus negative 1/2. minus x squared plus 1 to the 1/2 minus negative 1/2. All over, let's not forget our denominator, x squared plus 1 quantity squared, right? And so we're going to get is that, again, when I subtract a negative number, I am actually adding, okay? So I'm going to add the 1/2. So we're going to get x squared plus 1 to the negative 1/2. That's what we factored out. When I have negative 1/2 plus 1/2, so that's x squared plus 1, then to the 0 power. On the other one, I have 1/2 plus 1/2, so that's going to be x squared plus 1 to the 1 power, or the 2 over 2, however you want to think of it. Okay, still over x squared plus 1 squared. Okay, keeping this in mind, continue. So remember, any base raised to the 0 power will go to 1. So I have x squared plus 1 to negative 1/2. So then I have 1, then minus x squared plus 1 all over x squared plus 1 quantity squared. I can now multiply through that negative through. So I then have x squared plus 1 to negative 1/2, then 1 minus x squared minus 1 all over x squared plus 1 squared. And so I have a positive 1 and a negative 1, so they cancel with each other. I also need to make sure all my powers are positive. So this one here, I have to change to be a positive. So just like in the previous one, notice that it ends up being in the denominator if it's a negative power. So we can immediately just drop this into the denominator since there is one already there. So putting that into the denominator, I get negative x on the top squared all over x squared plus 1 to the 1/2. So notice that I took this part, this factor, and it drops down into the denominator and changes the sign to positive. Now we have x squared plus 1 squared. And remember, when two factors with the same base multiply, their powers add. And so we have negative x squared over x squared plus 1, and then it's 2 plus 1/2. So this ends up being negative x squared over x squared plus 1 to the 5/2. And we're done there.